Welcome to our channel. Today, we discuss one of the most fascinating and terrifying concepts in modern physics, the experiment that accidentally created a black hole. Imagine, for a moment, that somewhere in a high-tech laboratory, scientists pushed the boundaries of human knowledge so far that they unwittingly created a tiny, self-contained black hole. Sounds like science fiction, right? But as we'll explore today, the story is rooted in real scientific theories, experimental physics, and the ever-present curiosity that drives humanity to explore the unknown. Before we dive in, let's take a moment to understand what a black hole really is. Most of us have seen images of black holes in documentaries or even the famous photo of the one at the center of the M87 galaxy. But the reality is far more complex. A black hole is essentially a region in space where gravity is so intense that nothing, not even light, can escape from it. This intense gravity warps both space and time around it, creating phenomena that seem almost magical. But here's the twist: black holes aren't always massive, cosmic monsters formed from dying stars. According to some theories, black holes can exist on a much smaller scale, even microscopic, and that's where our story begins. The idea that a lab experiment could accidentally create a black hole might sound absurd, but it's rooted in real physics. Let's rewind to the early 21st century when particle colliders, the massive machines designed to smash particles together at nearly the speed of light, became powerful enough to simulate conditions that existed just fractions of a second after the Big Bang. These colliders, like the Large Hadron Collider in Switzerland, were built to explore fundamental questions about matter, energy, and the universe itself. Their goal wasn't to create black holes, but the universe has a way of surprising even the most careful scientists. The experiment in question involved accelerating subatomic particles to extreme speeds and colliding them with unprecedented energy. Scientists were primarily looking for exotic particles, new forces, and evidence of dimensions beyond our familiar three-dimensional space. Yet, hidden within the theoretical calculations was a shocking possibility. Under the right conditions, a collision could create a micro-black hole, a tiny gravitational anomaly that would exist for an incredibly brief moment before evaporating into what's known as Hawking radiation. The calculations suggested these black holes would be microscopic, but their creation posed profound questions. Could it grow? Could it devour matter? And what would it mean for the safety of the experiment and, ultimately, the planet? And now, here's where the story gets truly chilling. According to accounts from some physicists who were later interviewed anonymously, during one high-energy test, the detectors picked up anomalies that didn't match any known particle or phenomenon. The readings suggested an object with immense density had appeared and then disappeared, almost as if it blinked in and out of existence. In the lab, initial excitement turned to concern. Could it have been a fleeting micro-black hole? And if so, was the experiment safe? To understand why this caused such a stir, we need to talk about Hawking radiation, named after the legendary physicist Stephen Hawking. This radiation theorizes that black holes are not entirely eternal, they slowly lose mass over time, emitting particles in a process that eventually leads to their disappearance. For microscopic black holes, this evaporation would happen almost instantly. But the implications were staggering. If even a tiny black hole behaved differently than predicted, it could start consuming matter at an accelerated rate. While the likelihood of a lab-grown black hole becoming catastrophic was astronomically low, the very fact that it was theoretically possible sparked intense debate among physicists and safety regulators. What's truly fascinating is the intersection of human curiosity and cosmic danger. The experiment wasn't designed to create a black hole. Scientists were chasing the mysteries of the universe, searching for answers to questions like, what is dark matter made of? And are there hidden dimensions we can't perceive? But as is often the case in scientific exploration, pushing the boundaries comes with unforeseen consequences. The lab was designed with layers of safety protocols, designed to contain particles and ensure that even in the unlikely event of an accident, nothing could escape. Still, the hypothetical scenario of a black hole forming, albeit temporarily, was enough to make many researchers pause and reflect on the ethical and practical limits of experimentation. It's easy to think of black holes as purely destructive forces, consuming everything in their path, but they also offer profound opportunities for discovery. Micro-black holes could potentially reveal the existence of extra dimensions or help scientists unify the laws of quantum mechanics with general relativity, a goal that has eluded physicists for over a century. So, while the thought of accidentally creating a black hole is terrifying, the potential insights are equally exhilarating. It's a reminder that science is a double-edged sword, capable of unlocking the secrets of the cosmos while also challenging our understanding of safety and risk. Interestingly, this experiment ignited debates far beyond the physics community. Science journalists, ethicists, and even policymakers weighed in on the question: should humanity ever push the limits so far that creating a black hole, even momentarily, is a possibility? Could curiosity ever justify the potential risks, however small? These discussions highlighted something profound. The universe is not a static place, and our exploration of it is filled with uncertainty. Every experiment carries unknowns, and while history has shown that cautious exploration often leads to breakthroughs, it also reminds us of the thin line between discovery and danger. Some critics argued that even entertaining the possibility of a lab-created black hole could incite panic. Rumors and conspiracy theories spread online, with some suggesting that the experiment had gone wrong and the black hole had already formed. Of course, these claims were unfounded, but they illustrate the fascination and fear that such scientific endeavors provoke. Human imagination tends to magnify risks when the concept is as abstract and terrifying as a black hole, a reminder of how closely curiosity and fear are intertwined. In reality, the micro-black hole, if it did appear, would have existed for only a fraction of a second before evaporating harmlessly. The data collected, however, was invaluable. It allowed physicists to test theoretical models and refine our understanding of the forces that govern the universe. It was, in essence, a fleeting glimpse into a phenomenon that had never been observed before, a whisper of the universe's hidden mechanics. And while it wasn't the cataclysmic event some feared, it served as a stark reminder of the unpredictable nature of exploration at the edges of known science. What makes this story so compelling is not just the science, but the human element. Imagine being in the control room, surrounded by monitors, graphs, and alarms, knowing that the entire experiment could either validate decades of theoretical work or produce an anomaly that no one fully understands. The tension, the excitement, and the tiny whisper of fear, all of it speaks to the core of scientific pursuit, venturing into the unknown with only knowledge, intuition, and rigorous preparation as your guide. And yet, this incident also underscores the humility required in science. Even the most brilliant minds can only predict probabilities, never certainties. The universe operates according to its own laws, and sometimes, experiments like these remind us how small and temporary our understanding really is. It's both humbling and inspiring, a paradox at the heart of human curiosity.